So arrangement of electron in the orbit. Arrangement of electron in the orbit. Arrangement of electron in the orbit. So here there is a rule such that these are the energy level diagrams or the orbits concept, such that in the center there is nucleus, around the nucleus there is first orbit which is called K. The orbit is called K. Then around K, so first orbit is called K, second orbit is called L, third orbit is called M, fourth orbit is called N, and this is the nucleus. Nucleus consists of proton and neutron. This is K, this is L, this is M, and this is N. This is the model of atom. In the case Bohr put forward such that the arrangement of electrons inside the shell, such that there is a rule such that an orbit can accommodate a maximum number of number of 2n square electrons, a maximum number of 2n square electrons, where n is the number of orbit or shell. If we consider the first orbit, for first orbit, what about the first orbit? First orbit means n is equal to 1. Maximum number of electrons can accommodate in the first orbit is 2n square. 2n square, that is equal to 2 into, what about n? N is 1. 1 square, that is equal to 2 into 1 square is 1. That is 2 into 1 is 2. So a maximum number of 2 electrons can be accommodated in the first shell. A maximum number of 2 electrons can be accommodated in the first orbit. What about second orbit? For second orbit, what about n? N is equal to, second orbit means n is equal to 2. 2n square is equal to 2 into 2 square, that is equal to 2 into 2 square is 4, that is equal to 8. So a maximum number of 8 electrons can be accommodated in the second shell. What about third orbit? Third orbit, n is equal to 3, that is 2n square, that is equal to 2 into 3 square, that is equal to 2 into, what about 3 square is 9, 2 into 9 is 18. A maximum number of 18 electrons can be accommodated in the third shell. What about 4? If the fourth orbit n is equal to 4, that means 2n square equal 2 into, what about n? N is 4 square, that is 2 into, what about 4 square is 16, 2 into 16 is 32. That means a maximum number of 32 electrons can be accommodated in the fourth shell. So this is the rule of accommodating electrons in the shell. Such that there is also another rule. For the outermost shell, we can accommodate a maximum number of 8 electrons, that we can discuss in the part valency. So these are the arrangement. Now we want to discuss about or we can give some examples. For example, hydrogen atom. Hydrogen total number of electron is 1. How we can accommodate the 1 electron? So the center there is nucleus. There only one orbit is required. We can place 1 electron in the first orbit itself. So this is the arrangement of hydrogen. What about helium? Helium number of electron is 2. Helium number of electron is 2. So this is the configuration. This is the center nucleus. Now 2 electrons, a maximum number of 2 electrons can be accommodated in the first shell. So this is the arrangement. What about lithium? Lithium. For lithium, the number of electron is 3. Number of electrons in lithium is 3. So we can draw like, if only we draw the first shell, a first shell can accommodate a maximum number of 2 electrons. So the next third one is given to the next shell. So this is 3. So 3 can be accommodated. So what about sodium? Sodium. Sodium. Sodium, the number of electrons is 11. Sodium number of electrons is 11. Then center is the nucleus. First one, how much we can accommodate? 2. We can maximum number of 2. Second one, how much we can accommodate? Second one, we can accommodate a maximum number of 8. 1, 2, 3, 4, 5, 6, 7, 8. So 8 electrons. So 8 plus 2, 10. Right now 1 is balanced. That balanced one is filled in the third shell. So these are the arrangement of electrons. Right now, there is also one thing is that a maximum number of electrons that can be accommodated in the outermost shell is always 8. That part we can discuss. There is a confusion regarding that. That part we can discuss in valency part. And the shells are filled in stepwise manner. Only after filling the first shell we can use the second shell. Only after filling the second shell we can use the third shell. That is the configuration mode. That is the arrangement of electrons according to the Bohr concept. So this is about Bohr atom model. This is about Bohr atom model. So moving to the next topic, and this is an important topic regarding atomic structure called valence. So in the previous section, in the previous topic, we say that we concluded that there is a rule to fill the electrons in the orbit. But at that time, I just said that there is another thing, that there is a rule that we can accommodate a maximum number of 8 electrons in the outermost shell. What is the need of that 8 electrons? The thing is that the electrons in the outermost shell is called the electrons in the outermost shell is called valence electrons. Valence electrons. The electrons in the outermost shell is called a valence electron, and a maximum number of 8 electrons can be accommodated in the outermost shell. What is the need of that 8 electrons? Because Bohr says that atom is stable. To achieve the stability or to complete the octet, the term octet, to complete the octet, there is a need of 8 electrons in the outermost shell. So a maximum number of 8 electrons can be accommodated in the outermost shell, except hydrogen and helium. Hydrogen consists of only 1 electron and helium consists of only 2 electrons. So here in the case, how to find valency? What is mean by valency? The combining capacity is called valency. Combining capacity is called